Hey everybody, I'm Mr. Klein. I'm where it's at. I'm Mr. Klein. I'm in a hat. And today we're going to be talking about continuity. I think I would like to begin here. I would like you to draw a picture of yourself driving your car. Oh, fumes coming out here. Okay, so there you are. You're in your car and you're driving along in your car. You're driving, you're driving, you're driving, you're driving. Oh my goodness, stop! There's a hole! There is a hole in the road, and as a result, you can not continue. And if you cannot continue, that means that the road is not continuous. Today, we're going to be talking about something called continuity, and as a rule, you can say that f of x is continuous at x equals c if you can drive over it. Okay, so for instance, right here at C, can I drive over the graph? You bet I can. This one's continuous at C. Right here, can I drive over the function at C? Yeah, I got to make a right turn, but I can do it. So this one is continuous. However, if you look at the next page, can I drive over this road at C? No, there's a hole in it. So this one is not continuous. And right here, there's a hole in this one too. So this one is not continuous. Here's something that you need to know. If you have a place where the curve is not continuous, that is called a discontinuity. And if you look at this one and this one, we could fix the discontinuity just by plugging that hole, right? You add 1 point, you've removed the discontinuity. You move 1 point, you removed the discontinuity. So these two right here have a name. They are called removable discontinuities. All right. All right, next up, let's keep going. This one right here, you're driving along, you get to this point. Can you drive over it? No, not unless your car can fly. So this one is discontinuous. Now, in order to get from here to here, you would either have to take a big step or jump. So your book is going to call this a step discontinuity. And sometimes in pre-calc, I think they call it a jump discontinuity. Doesn't really matter. The last one right here. You're driving along, you're driving along, you're driving along. How long will it take you to get over the road? The answer, forever. This road never ends, and you're never going to cross that line. So this one is also a discontinuity, and because the road goes on forever, we say it is an infinite discontinuity. All right, so we know what continuity is. We know that there are 3 types of continuity. Next up, we need a more formal definition of what continuity means. So let me give you one. In math, we say that a function is continuous at a point IFF. Have you seen IFF before? IFF means if and only if. Mathematicians are lazy. They don't like to write, so we just write IFF. And it's continuous only if it meets these three conditions. 1, 2, 3. The first is this. F of C exists. Another way to put that is that at the point we're talking about, the function has a value. Next one, the limit as x approaches C, as x approaches C of our function also exists. Okay, so that's another way of saying it has a limit. Now there's one more condition, and I bet you some of you guys can guess what it is, right? If, hang on, let's work on that. There we go. If it has to have a value and it has to have a limit, what else has to be true? The answer is this. The value of the function and the limit, they have to be the same. So value is equal to limit. All right, so let's play around with this and see why some of these are continuous and not continuous based on our new definition. Take a look at number 1. All right, so if I asked you, what is the value? You would say, well, if I plug in C, I'm going to get 7. And if I asked you, what is the limit? You would say, well, from this side, it's getting close to 7. And from this side, it's also getting close to 7. So this would be 7. And then if I said, is the value equal to the limit? You would say yes, and therefore this one is continuous. It passed all 3 conditions. Likewise, look at this one right here, the one with the little pointy guy. On this one, if I asked you what is the value, you'd say, well, when I plug in C, I get boop, 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 I get 20. And if I said, what's the limit? You would say, well, from this side, it's getting close to 20. And from this side, it is also getting close to 20. So the limit is 20, which means is the value equal to the limit? Yes. And we have ourselves continuity. Now, the more interesting ones are on the next page. Let's look at the ones that are discontinuous. Okay. Take a look at the first one. If I asked you, does this function have a value at C? You would say, when I plug in C, there's a hole. So the value would be undefined. Now, right there, we know that it's not going to be continuous, but let's keep going just for giggles. Does this one have a limit? Well, on this side, the function appears to be getting close to 3. And on this side, the function also appears to be getting close to 3. Both sides are coming to the same place, so our limit would be 3. Is the value equal to the limit? Well, the value doesn't exist, so our answer would be no. And this one is a discontinuity. This one. Is there a value? Boop, 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 boop. Yeah, it's right here. It's 8. Is there a limit? Well, on this side, the function is approaching 5. And on the other side, the function is also approaching 5. So if the left and the right side are both approaching a number, our answer is going to be yes, here's the limit. But are the value and the limit equal to each other? No. So once again, we have a discontinuity. Let's keep rocking. Take a look at the next one. On the next one, is there a value? Yes. The value is 5 because that's where the dark dot is. Is there a limit? Well, the limit from the left side would be 5, and the limit from the right side would be 12, and they are different. So we would say the limit does not exist. So can the value be equal to the limit? No. Last one. This one's very disappointing. Is there a value? No, it is undefined. There's no value here. Is there a limit? No, it does not exist. There's no number that it is approaching. If you wanted to say positive infinity, I would also say that. Okay, so can the value possibly be equal to the limit? No, that's why we get a discontinuity. All right, so last piece here is I want you to tell me what is special about the removable discontinuities. What do they have that the step and the infinite do not? And the answer is they are the only discontinuities that have a limit. So a removable is a discontinuity with a limit. If you look at the steps, the step does not have a limit in general, but you'll notice that it does have limits on the left and the right side. So a step is a discontinuity with left and right limits that are not equal to each other.